Hello students, this video is about the oxides and the trends in the periodic table. So let's get started. This is the oxygen atom and this is the oxide ion. The electronic configuration of oxygen is 2, 6. The inner shell has 2 electrons and the outer shell has 6 electrons. Oxygen belongs to the 6th group of the periodic table, so it has 6 valence electrons. It needs 2 electrons to complete its octet. So when it gains 2 electrons, it has -2 charge and the electronic configuration is 2, 8, -2. This is the oxide ion. Now you know that this is the oxide ion and this video deals with the oxides. There are three types of oxides: basic oxide, amphoteric oxide and acidic oxide. Base is any species that gives OH negative ions in aqueous solution, and acid is any species that gives H positive ions in aqueous solution. The metallic oxides are the basic oxides and the non-metallic oxides are the acidic oxides. Students, I repeat, keep it in mind that the metallic oxides which are on the left side of the periodic table are the basic oxides and the non-metallic oxides which are on the right side of the periodic table are the acidic oxides. In between these two oxides, there is another type of oxide which is amphoteric oxide, and this behaves both like an acid or a base. Now here you see the reaction of metal oxide with water. When ionic solid, it dissolves in water, the aqueous solution will be composed up of aqueous metal ion, which is the cation, and the oxide ion, which is the anion. The oxide ion, it is a very strong anion due to its very small size and high charge. Since OH negative ion, it is the strongest base that can persist in water, the oxide ion, it reacts quantitatively with water to generate OH negative ions. The O negative 2, that is the oxide ion, has great affinity for proton, that is H positive, and cannot exist alone in aqueous solution. Therefore, it immediately takes the proton, that is H positive, from water and forms OH negative ion. In this way, the concentration of OH negative ions increases and solution becomes basic. Sodium and magnesium positive 2, it don't react with water, but oxide, it does react with water. As you can see in the diagram, this is a sodium oxide compound, and when it gets dissolved in water, it dissociates into sodium positive ion and oxide ion. The sodium positive ion, it has relatively low charge density, so only ion dipole interaction exists between sodium cation and the water molecule. But on the other hand, the oxide ion, it has very high charge density due to its small size, so it breaks the water molecule. The H positive ion, that is from the water, it reacts with the O negative 2, that is the oxide ion, to form another OH negative ion, and in this way the concentration of hydroxide ion increases in the solution and the solution becomes basic. So this is the whole mechanism. I hope the concept is clear now. Now let's see what an amphoteric oxide is. The amphoteric oxide behaves as a base when react with strong acid and behaves as an acid when react with a strong base. The example are beryllium oxide, aluminum oxide, bismuth oxide, and zinc oxide. Now let's take an example of aluminum oxide. The presence of O negative 2 ion, that is the oxide ion, in this oxide, it makes aluminum oxide basic, that is able to react with acid. However, the Al positive 3 ion, the aluminum, it belongs to the third group, so it has positive 3 charge. This ion has high positive charge density. Hence, it is strongly attracted to and reacts with electron-rich OH negative ions present in a base to form aluminate ion. Like here you see, the aluminium forms, this is the aluminium ion, it has high charge density, it has positive 3 charge, so it forms coordinate covalent bond or dative bonds with OH negative ions, as you can see here, to form aluminate ion. So aluminum oxide, it's an amphoteric oxide, it can behave both as an acid or a base. Now let's see zinc oxide and prove by reactions that it is also an amphoteric oxide and it can react both with an acid or a base. Zinc oxide, when reacts with acid, that is this is sulfuric acid, it forms zinc sulfate and water, and when it reacts with sodium hydroxide, which is a very strong base, it forms sodium zincate, which is Na2ZnOH4. So zinc oxide, it is also an amphoteric oxide like aluminum oxide, and it can react both with an acid and a base. Now let's see the nature of oxide in a period. How does the nature of oxide change from basic to acidic character when one moves from left to right in a period. When one moves or travels from left to right in a period, the oxide becomes more and more acidic in character. The electropositive character, it decreases from left to right, and the electronegative character, it increases. Now you see that this is the third period of the periodic table. Sodium oxide, magnesium oxide, aluminium oxide, silicon oxide, phosphorus pentoxide, sulfur trioxide, and dichlorine heptoxide. Now in this case, these two are strongly basic because they are the metallic oxide. They are on the left side of the periodic table. Aluminum oxide, as I discussed earlier, this is the amphoteric oxide. Silicon oxide, phosphorus pentoxide, these are the weak acids. And sulfur trioxide and dichlorine heptoxide, these are strongly acidic. Now in the periodic table, this is the third period. The sodium and magnesium, their oxides are very strongly basic. Aluminium, its oxide is amphoteric. Silicon and phosphorus oxide are weak acid, and sulfur and chlorine oxides are strong acids. So this is the trend in the periodic table. The oxides on the left side of the periodic table are basic, and the oxides on the right side of the periodic table are acidic. So the trend is from basic to acidic. Now the question is, how does the acidic nature of oxide change with the increase of the oxidation number of the central atom? The oxidation number. Now, students, you should know that when the oxidation number of the central atom increases, the oxides become more and more acidic in nature. When the oxidation number increases, the acidic nature increases. The reason is the polarizing power. The polarizing power of the cation, that is, its ability to distort the electron cloud of the anion. The reason is the polarizing power of the cation. The central atom, the polarizing power, when the central atom increases, it will have greater tendency to attract OH negative ions, that is the hydroxide ions, and H positive ions will be released in the solution, and the solution will become acidic, because acid is a species that forms H positive ions in aqueous solutions. Now in this case, you see that it's the ascending order as the oxidation state is increasing in the case of manganese. This is manganese oxide, this is manganese trioxide, this is manganese dioxide, and this is manganese heptoxide. Now you see that the oxidation state is increasing, so the acidic nature is also increasing. So the acidic nature in this case, where the manganese has positive 7 oxidation state, manganese heptoxide, it has the most acidic nature. The oxide of manganese heptoxide, it will be having the most acidic nature. Now this is the cation. As the oxidation state increases, what happens? The polarizing power increases and it attracts the OH negative ions towards itself, and this is the region where the electrons are shared. So the cation with higher oxidation state, it will attract the OH negative ions in the solution, and H positive ions will be released, and the solution will become acidic, and that is how the acidic nature increases. Now let's see the reaction of non-metal oxides with water. Carbon dioxide, carbon belongs to the fourth group and it is a non-metal, so it should be in acidic nature. Carbon dioxide acidic nature is shown like this. When carbon dioxide reacts with water, it forms carbonic acid. Carbonic acid is an acid, so non-metallic oxides, when they are dissolved in water, they form acids. Now you can see here, this is the structure of the carbonic acid, H2CO3. This is the carbonic acid. Again, this is the reaction. Carbon dioxide, when it reacts with water, it forms carbonic acid, and carbonic acid, it's in equilibrium, like it forms H positive species in the aqueous solution and forms bicarbonate ion, and again the another hydrogen ion is liberated in the solution and it forms carbonate ion. These are the conjugate bases, and this is the hydrogen ion which is released in the solution. So that is why carbonic acid is an acid, and when carbon dioxide, which is a non-metallic oxide, it dissolves in water, it forms an acid. Now students, the question is, that the basic character of oxide increases down the group. Justify it. As we go down the group, the size of the atom increases. You know very well the size of the atom increases because the number of shell increases as we go down the group. So as the size increases, the ionization energy decreases. Why? Because the distance from the nucleus, the outermost electron, and the nucleus, it becomes greater. So the energy to remove the valence electrons, it becomes lesser. So ionization energy, it decreases. So the atoms are better at giving their electrons. Water takes these electrons and then yields OH negative ions. So the nature of oxide, it becomes basic as we go down the group. In short, you can say that when the atomic size increases, the electropositivity increases. That is, the ability to lose electrons increases and the basic character increases. I repeat, when the atomic size increases down the group, the electropositivity increases and the ability to give electron increases and the basic character increases. As you can see in this group, this is the second group of the periodic table, the alkaline earth metal, beryllium oxide, magnesium oxide, calcium oxide, strontium oxide, and barium oxide. Barium oxide has the highest basic character because the basic character increases as we go down the group because the atomic size increases, the electropositivity increases, and the ability to give electron increases, so the basic character increases. I hope this video was helpful. If you like this video, please like, share, comment, and subscribe. Thanks for watching. Wish you all the best.